Great to see you all here. Somebody's drink bottle, I'll move that over there. It's a safer place. So who was here this afternoon? Yep, a few of you, that's great. Well, as Pastor Kevin said, if you've got questions on the biology topic, then we'll pick those up a little bit later on. So this afternoon we talked about geology and the Bible, and then we talked about biology and the Bible. And I want to talk briefly tonight on astronomy and the Bible, but I want to just pick one particular aspect of astronomy, and that is to do with our moon. And the moon is absolutely amazing. Not only is it amazing, but it also has to be young. It cannot be 4.5 billion years old as we are taught in the evolutionary scheme of things. And I'm going to explain why. Now, it's a bit cloudy out there tonight, but we've around full moon right now. So when you get a chance to see the moon, take a look at it, remember what I'm saying tonight, and see if you can recognise some of the things about the moon. But before I get into that, people often say that this whole issue of evolution versus creation is just a side issue. And I just want to share the results of this survey work that was done by the McCrindle group a few years back now. But surveying people in Australia, it turns out that over half of all Australians say that science and evolution is an issue that blocks their interest in Christianity. Isn't that interesting? That means that every second person that you see out in the street, on average, will find this issue as Christianity is of no value because science has proven the Bible to be wrong, right at the very beginning. But they also found that about a third of people believe that it's a significant blockage. In other words, they don't want to even talk to you about it. They're totally closed. A third of the people that we might run into at random are just closed to the Christian gospel message. Isn't that a tragedy? You see, there's such an importance for us as Christians to be equipped with how to share our faith in this very secular age of ours. And as you doubtless know, up on the tables at the back we have quite a wide range of materials, but one of the items which is very important, which I've mentioned earlier and I'll mention again tonight, is Creation magazine. And I talk about it because it's written for lay people. It's something that you can give to someone as a gift to read, and it's tremendously powerful in its impact. We have so many testimonies of the impact that the magazine has in people's lives. Of course, there's our website, which I talked about last night and touched on briefly today, and that's what the front page looks like. There's something new there every single day. Up in the top right-hand corner is a search window. It gives you access to over 14,000 different articles and items of interest, all aimed at encouraging you in your faith. And we recommend people jump on every day, have a quick look, read the article. It may be of interest to you or not, but have a look anyway because it's God-honouring, faith-building material. And of course you all now know what the web address is, don't you? Don't you? I hope you do. So I'm going to bring it up on the screen in a minute. So you're ready to say it with me when it comes up? So if you want to know anything about creation, you just go to creation.com. You've got it. Very good. We also mentioned that we have a free email newsletter service. We call it Creation Info Bites. Comes out about once every 2 weeks. We don't spam your inbox, but it's a great way of keeping up to date with what is current on the website and latest issues and so on. And it equips you then to be able to share this message with other people. Now, up on the tables at the back, oh, by the way, the first email you get will give you access to this documentary. Creatures do change, but that's not evolution. You often hear people say, but evolution is just change over time. I don't know if you've ever heard that, but some people run that line, but actually it is not. And we talked about that in the biology session this afternoon. So this is a great documentary. It comes with your first email, and there's a form up there on the tables at the back. You can either fill it out the long way. It's advancing all by itself for some reason. Not sure what I'm doing. You can fill it out the old school way, but it's by writing your name and email address and so on in it, or just use the QR code. So here's an amazing picture that was taken from the Galileo spacecraft, And it's a picture of the Earth and the Moon, and it's not a collage. It's not made up from separate photos. It's a single photograph taken from 6 million kilometres away from the Earth. And what a magnificent sight it is. Can you see how rich and blue our planet Earth is? And there's this rather brown-looking ordinary sphere out there, which is the Moon. Now, the Moon, interestingly, always has one side facing us. Now, I used to wonder, how come the Moon spins on its axis in exactly the same time that it takes for it to orbit once around the Earth? And it never varies. It seemed like an amazing coincidence to me, until I figured out that actually it's not a coincidence at all, because the Moon is gravitationally locked so that one face always looks at the Earth. And you might think, well, how does that happen? Well, it's a process called tidal locking. And because of the gravitational field of the Earth over the Moon, it actually slightly distorts the Moon. So the side of the Moon closest to the Earth gets a slightly stronger force of gravity acting on it than the side furthest away from the Earth. And that has the effect of slightly stretching it, nowhere near as much as that, right? That's a massive exaggeration. But the Moon is not a sphere, it's just slightly oblate or flattened like that. So what happens is, if the Moon tries to turn away, there's a torque automatically exerted on the Moon that pulls it back again. So it's actually locked into place. And that's why we only ever see the one face. Now, when you look at the face of the Moon, there's some very obvious features. Those large, dark areas that are called maria, that is Latin for seas. Now, many, many years ago, people looking up at the Moon thought that maybe these dark areas were lakes or oceans or something, not knowing what the surface of the Moon was like. So that's where the name came from. But it turns out they're actually massive areas where there's been impacts on the surface of the Moon, probably from asteroid-sized objects, and that has shattered the crust of the Moon and released enormous amounts of lava which have flowed out rapidly over the surface of the Moon and then set hard. Now, the lava sets as a basalt rock, which is sort of black in colour, which is why those areas are much, much darker. Now, there are lots and lots of small craters that are also visible, and you can probably see those, and they represent much, much smaller objects which have been raining down onto the Moon for thousands of years. But the maria are very interesting because they are so big. They speak of massive objects impacting the surface of the Moon. Now, it's only been recently, relatively recently, that we've been able to see the other side of the Moon. And we've been able to do that by having spacecraft go into orbit around the Moon with cameras and signal back the information that they have found. And when you look at the other side of the Moon, you discover it's very, very different from the side that faces us. And you take one look at that and it's obvious how different it is. Now, I can see maybe one or two darker areas, small maria perhaps on the other side, lots and lots of small craters still. That's pretty much the same as on the side facing us, but the difference in the maria are spectacular. Now, just a word of warning, you jump onto AI and ask AI all sorts of questions. Sometimes AI doesn't actually tell you the truth. And so I asked AI, are the craters around the Moon uniformly distributed? And it came back and told me, yes, they are. Really? Just take a look at that. They're obviously not. So the large maria represent huge impacts from massive objects, probably asteroid size, which pounded into the Moon. But why are they only on the one side? Now, when we think about it, the Moon spins on its axis about once every 27 or so days, and that's how long it takes to go around the Earth. And if we just take a look at this, you can imagine an asteroid swarm coming past the Earth and the Moon and impacting. Now, in the space of a day, the Moon moves about as much as I've shown on that chart, approximately. But in a day, of course, the Earth rotates completely on its axis. So just imagine a swarm of asteroids coming in over a very short space of time. You can see that some of them will hit the moon, some will hit the Earth, some will just miss both. But the moon doesn't turn very much in the space of one day, so only one side would be impacted. If that swarm of asteroids had lasted for, say, a week or 2 weeks, then the moon in 2 weeks actually rotates completely around, so the distribution of Maria would be uniform all the way around the moon. Even if it lasted for a week, then you would see at least 3/4 of the moon's surface impacted by these asteroids. But it's just the face that looks at us, which suggests to me that it would have happened very quickly indeed, probably only about a day or maybe 2. So what could have produced such things? Well, I think the effects of these are very obvious by looking at the moon. Some people believe that maybe this swarm of asteroids, very short, sharp burst of them on impacting the Earth, actually triggered, were part of the trigger mechanisms for the flood of Noah. Remember in the previous talks we've shown how the Earth's crust is broken up into huge tectonic plates. Maybe the breaking up of those plates occurred at this time as these asteroids swarmed past in a very short burst. So when you look up at the moon next and you see all those dark Maria, when the clouds break tonight or tomorrow or whenever, take a look. There is a fingerprint, if you like, of God's past judgment that came about 4,500 years ago. So let's have a look at some of the features of the moon. Now, I believe the moon was designed by God for a special purpose. And we'll read about that shortly in the book of Genesis. But the moon is actually very large compared with the Earth. It's about 1/80th of the Earth's mass and about 1/4 of its diameter. Now that doesn't sound much, but you compare that with other moons in our solar system. The first thing to notice is that the Earth is the only planet in our solar system with just one moon. So all the planets that have moons have more than one. And some have a lot. For instance, Saturn has 274 of them. 128 of them, about half, were only confirmed just a couple of months back in March of this year. Uranus has 28 moons and Neptune has 16, but Earth has just one. Also, the size of those moons are very, very small compared with the size of the Earth's moon. Typically, a moon is about 1/1000th the mass of the planet that it orbits. But our moon is just 1/80th of the mass of the Earth. So we have one very big moon, nothing like any of the other planets in our solar system. Now the size of the moon is quite important. It permits solar eclipses to happen. And it turns out that even though the moon is 400 times smaller than the sun, it's 400 times closer. And that means that when we look up into the sky, the moon looks about the same size as what the sun is, which means that every now and again the moon will come between us and the sun, and that is what produces a total solar eclipse. And there's a photograph of one. You can just see the light, the ring around the moon, and in a total solar eclipse the sun is totally blocked from the Earth, apart from just the fringes around the side. Now the shadow that's produced on the Earth is actually quite small. This is a photograph from a satellite during a total solar eclipse, and you can see the shadow of the moon passing over Mexico there. It's not very big, about 200 kilometres in diameter in fact. Has anybody ever experienced a total solar eclipse? Has anyone been in the path of a total solar eclipse? No? You have, yeah? It's an amazing experience, isn't it? So back in the middle 70s, 1970, my wife and I, would you believe, we were actually married then. We've been married for 51 years. And we travelled down to the south of New South Wales and positioned ourselves on a farmer's property who'd opened it up for this purpose. And we set up our cameras and tripods, and there were people with telescopes and all sorts of things. We had it all timed right down to the second when we have to do this and when we would do that and everything else. And everyone was ready, and it was cloudy. So, we didn't see the eclipse, but we experienced the eclipse. And it's really quite something, because all of a sudden it starts to go dark. You don't really notice the onset. It's only when it's almost total that you suddenly realise it's getting dark. The birds all began to try and roost because they thought it was evening. And because the warmth of the sun was now blocked, the air grew cold and a cold wind sprang up. Very eerie kind of sensation. I can imagine centuries ago people not knowing what was going on would panic in the middle of a total solar eclipse. And then after about 2 minutes it started to get light again, and the birds all came back and the wind died down and the warmth came back and it was all normal again. But quite a remarkable event. Maybe one of these days I'll get to actually get in the line of an eclipse and it won't be cloudy, he's hoping. So total solar eclipses, though, are very important because through those we've been able to learn a great deal about our sun. We discovered, for instance, the element helium, which is named after the Greek god Helios, and that's where that element was discovered. We also found much about the outer atmosphere surrounding the sun by making observations during total solar eclipses. Also, Einstein's theory, general theory of relativity, was confirmed by a solar eclipse. And Einstein predicted that light would be bent in a strong gravitational field. So during a total solar eclipse, astronomers took photographs of the stars around where the sun was, which of course you couldn't normally see in daylight hours. And sure enough, there were stars which should have been behind the sun, blocked by it, became visible at the side, so the light from those stars was being bent around the sun to the Earth. So Einstein's general theory of relativity was confirmed during a total solar eclipse. Well, you can also get lunar eclipses, which of course is when the moon passes into the shadow of the Earth. Now, these occur much more frequently than total solar eclipses. And I'm sure you all would have experienced a total lunar eclipse. When you look up at the moon, it looks this sort of red colour. It's sometimes called a blood moon. And from observing lunar eclipses, the ancient Greeks knew that the Earth was spherical because of the shape of the Earth's shadow. So they took careful note of what the shadow of the Earth looked like as the moon moved through the eclipse. And by drawing it carefully, they realised there was a circular shadow. And how would something cast a circular shadow unless it was in fact a sphere? So somewhere in the order of 200 plus BC, we knew that the Earth was a sphere. Sadly today, there are people who believe the Earth is flat. And I can assure you that it is not. And as I shared earlier on, and last night anyway, that I spent some 30 years designing communications spacecraft which orbit the Earth, and you have little dishes around on rooftops pointing up at those satellites, and none of that would even work if the Earth was flat. And companies like Optus would not spend hundreds of millions of dollars purchasing satellite systems if they didn't work. So we've known for a couple of thousand years plus now that the Earth is a sphere. And if you are encountering people telling you about a flat Earth, we have some excellent articles on our website. Just go into the website, type in flat Earth into the search window, and you'll find those. So much for the flat Earth myth. And I just want to show you this photograph because I think it's really cool. This was a total lunar eclipse that someone very cleverly photographed with the Opera House in the foreground. But the moon does other things than just produce pretty pictures. Its actions, along with the action of the sun, produces tides. And when the sun, earth and moon are all lined up, we have what are called spring tides. They're the highest ones. And if they are at right angles together, you have what are called the neap tides, which are not as large as the spring tides. So if you ever go fishing, you'll always want to check up on the tide chart. And here you can see what the tides look like. And you can see the ones with the smaller range between the peaks. On the left-hand side, they're the so-called neap tides, and the ones on the right are the spring tides. But the tides are very important. You see, tides flush out the coastal waters to make sure that they're well oxygenated and kept fresh. And that means that marine life, coastal marine life, can thrive. Now, if the moon was too close to us, then the tides would be very, very large, and they'd be destructive. They wouldn't be conducive to life at all. Conversely, if the moon was too far away, the tides would be ineffective, and we wouldn't have thriving coastal life. So tides are evidence of design. You see, the Earth-Moon system is a wonderful example of design. And in the book of Isaiah, God says, "For this is what the Lord says, He who created the heavens, He is God. He who fashioned and made the earth, He founded it. He did not create it to be empty, but formed it to be inhabited." You see, this earth, the universe in fact, was created to be a home for man. Man made in God's image. That's how precious we are to Him. And so He's made a beautiful environment for us to live in. Well, the moon is actually something of an embarrassment for the secular scientist who tries to disregard the possibility of there being a God, or who even actively believes there is no God. Now, if you believe there's no God and you are forced to use naturalistic explanations for everything, then you need to come up with an explanation for how did the moon come to be. And there have been a number of different theories that the secularists have proposed. The first one was called the fission theory. This was thought of by a guy called George Darwin, that's Charles Darwin's son. He was a mathematician and astronomer. And his idea was that the molten Earth in its early stages spun so fast that a lump flew off, and that solidified and became the moon. But this idea has got a lot of problems, and no one subscribes to it today. The moon is too chemically different from the Earth. In particular, the moon rocks lack iron, and if it came off as a part of the Earth, you'd expect almost identical geochemical properties. Also, the moon's orbit plane would be in the Earth's equatorial plane, but it's not. It's inclined by about 5 degrees, and also the Earth could not have spun so fast and still survived. So the fission theory, no one really subscribes to today. Then the next idea came up, and that was the capture theory. And the idea is that maybe the moon was wandering through our solar system, came too close to the Earth and got captured by it, and here it is now orbiting our planet. Well, when I worked in the aerospace industry, I got to know a little bit about the dynamics of the orbits of spacecraft. And to launch a satellite into a geostationary orbit, that's an orbit directly above the equator and at the right altitude so that it takes as long to go around the Earth as the Earth does to rotate. And that means, by the way, that the satellite will appear to be fixed in the sky. It's actually moving at about 3 kilometres a second, but it looks as though it's stationary. And that's why you can have small dishes that are very simple and cheap, and they don't have to follow the satellite around the sky. They just look in the one area all the time. So to get into that orbit, what happens is the satellite gets launched at a particular location. It gets injected into a very elliptical orbit called the geostationary transfer orbit. Now, there are some rockets on board the satellite which are then fired at exactly the right time at the highest, furthest point, that is the apogee. And progressively, the orbit is made more and more circular, and any orbit inclination is taken out until it's in the correct plane. Now, all of that requires very careful calculation, and it's a carefully controlled sequence of firings to get the satellite injected into the correct orbit. So let's think about the probability of that happening for the moon. Got to remember, it just had to wander absently into the solar system and end up coming too close to the Earth. It's far more likely it would have just had its trajectory deflected as it zapped around the moon. Very unlikely that it would actually have been captured. And if it was captured, it's most likely it would have been captured into a highly elliptical orbit. But the moon's orbit is almost perfectly circular, slightly elliptical, but only slightly. So it's extremely unlikely that it would end up in the orbit that it has today. So people didn't really put much value on the capture theory. They thought, yeah, maybe. It's a possibility, though. It's a possibility. And then the next idea Let me just summarise that. Extremely unlikely to be captured. The Earth and Moon, by the way, have nearly identical geochemical properties. Now, this is a problem because if it wandered in from outside the solar system, what's the chance that the rocks on the Moon would be very, very similar to rocks on the Earth? Most unlikely, in fact. So that's a bit of a challenge. So the capture theory, yeah, it's got its problems. So then they came up with the co-accretion or co-creation theory. And this idea is that the so-called swirling cloud of dust and gas that formed the Earth also formed the Moon at the same time. And that sounds as though that might be right, but there are some significant issues. Again, it doesn't account for the Moon's low iron content. Now, the Moon's rocks are similar to, but a little different from the rocks of the Earth, particularly with regards to the element iron. There's not much iron in Moon rocks. Everything else is about the same. But that difference is very important because if it had formed from the same swirling cloud of dust and gas, you'd expect it to have very similar geochemical properties. The Moon, though, should be in the Earth's equatorial plane again because of the conservation of angular momentum, but it's not. And in any case, there's insufficient gravitational attraction for accretion to even work. It's a very long bow to draw. And the Earth-Moon system has too much angular momentum. It means it's spinning too fast. The Earth and Moon, it just doesn't fit the idea of this swirling cloud of dust and gas. So that doesn't stack up too well either. Now, back in the late 60s, early 70s, the Apollo program was to, among other things, test which of the then current theories for the origin of the Moon might be right. And the way they were going to test was to collect rocks from the surface of the Moon, bring them back to the Earth, and then do an analysis on the chemistry of the rocks. And that's what they did. And as a result of that, both the capture theory and the co-creation theory or co-accretion models were eliminated. So that left a bit of a problem because now there were no standing theories left at all. So in the early 80s, there was a conference convened on the origin of the Moon, held in 1984, and they revived the old impact theory. Now, this had first come up in the 1940s, and someone had said maybe the Moon was caused by an impact between the Earth in its early stages and some other object, and the debris formed the Moon. But no one really took it very seriously. It wasn't actually a contender as a model until after the Apollo missions had eliminated everything else. And so, as a result of that, the giant impact hypothesis was declared the most plausible. But the reason it's the most plausible is because all the other models had fallen over. So that it was really the only game that was in town. So the giant impact hypothesis is that there was some Mars-sized object, they called it Theia, which collided with the Earth, and the debris formed the Moon. And but there are some interesting problems. The Earth and the Moon are almost identical geochemically, apart from that slight difference in the amount of iron. But depending on how you construct the models, the angle of impact and all that, the Moon should have mostly the chemical composition of the impactor, Theia. But it's a long bow to believe that Theia would have been almost identical to the Earth because it came from who knows where, outside the solar system perhaps. Also, it's very difficult to get a model that accounts for the orbit of the Moon. So if you fiddle the angle of incidence for the impact to get the orbit to work, then it turns out that the geochemical properties don't fit. Or if the geochemical properties work, then the orbit's all wrong. And so the problem is that we don't have a self-consistent model for the origin on the Moon. Also, anything like water on the Moon wouldn't have survived an impact. It would have boiled away with all that dissipated energy and heat. But there is water on the Moon. There's water ice in the shadows of craters near the poles where the sun never shines. And also there's water in the form of hydroxyl inside the minerals of the Moon rocks themselves. And there's this perennial question, why do we have only one Moon? Surely an impact like that would have sent debris everywhere. We would expect to have multiple small moons, not just one very big one. So the strongest argument in favour of the giant impact hypothesis is that all the other models fail. But really, it doesn't have good evidential support at all. Now, there's a very famous planetary scientist, a man called Erwin Shapiro, who's not a Christian, and he was summarising all of these models for the origin of the moon, and he summed it up very eloquently. He said, since there are no good explanations, meaning naturalistic explanations, remember they won't admit the possibility of a supernatural explanation, so since there are no good explanations, the best explanation is that the moon is an illusion. Now, of course, he's joking, all right? But it just serves to illustrate that the experts have got no idea. There is no compelling, self-consistent model to explain the existence of the moon. But you know what? The true origin of the moon is spelled out for us in God's word. And God tells us in Genesis chapter 1, God said, let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and seasons, for days and years. And let them be lights in the expanse of the heavens to give light upon the earth. And it was so. And God made two great lights, the greater light to rule the day and the lesser light to rule the night, and the stars also. And God set them in the expanse of the heavens to give light on the earth, to rule over the day and over the night, and to separate the light from the darkness. And God saw that it was good. You see, that's where the moon came from. And according to the biblical timelines, about 6,000 years ago, God created the Earth-Moon system. So when you step outside and look up at the moon, you look at those dark areas, those Maria, you see, I believe, evidence of God's judgment that came at the time of the flood. And we also see wonderful design features that makes life on Earth so much better because of the moon. Now, last night I shared a timeline of Bible history. And I showed the time from creation week to the time of Abraham as being about 2,000 years. And remember I said from Abraham to Jesus was about 2,000 years. And from Jesus to the present day is about 2,000 years. So according to the Bible, here we are about 6,000 years after the creation. So if that's true, then that means the moon and the earth are only about 6,000 years old. But let's have a look at some interactions that take place. Now, the Earth is not rigid, by the way, the moon here, let me explain. The moon has or applies a gravitational field over the Earth in the same way that the Earth does to the moon. So it works back again in the opposite direction. So it slightly distorts the Earth. And that has the effect that as the Earth turns, then it is slowing down, is like a brake being applied because of the moon, but that effect also accelerates the moon and makes it go faster in its orbit. So if the moon is speeding up in its orbit, it means it's spiralling outwards. It's going out further and further. Now, when the Apollo missions were on the moon, they left behind a number of experiments, and one of them was to leave a corner reflector. Actually, there were several. And a corner reflector is a little device that shines light back in exactly the same direction as it arrived. You probably know as you drive along at night, you see those little cat's eyes on the road. The headlights from your car shine onto those. They're little corner reflectors, and the light comes straight back to you so you can see them. So it's the same principle. And by firing high-powered lasers at these corner reflectors on the surface of the moon, astronomers are able to determine very, very precisely the distance between us and the moon. And it turns out the moon is spiralling outwards at the dizzying rate of 3.8 centimetres every year. Now, you might think, big deal. It's about that far. Really? Who cares? Well, it's kind of interesting because you can wind this process backwards and see how close the moon could have got to the Earth and how long ago. And the closest it could ever possibly have got is what's called the Roche limit. And at that point, the gravitational gradient of the Earth across the moon would be so great it would tear the moon apart. Now, it doesn't have to get even that close by any means, but let's say it did. Let's say we could go all the way back to that. Do you know that would have been reached in less than 1.5 billion years? But hang on a minute. We're told in the evolutionary story that the Earth-Moon system is 3 times older than that. So what we're observing today is not consistent with the claimed age. So astronomers contemplate this and they think, well, I wonder what... Well, by the way, you could never get anything like as close as the Roche limit. The moon was that close. Imagine the tides that we would have on the Earth. You would have tsunamis thundering across the land masses twice a day on every high tide. The Earth would be completely uninhabitable. So it's obviously an outside limit. But here's an interesting quote. This guy was contemplating how to solve this problem, and he thought the dissipation of tidal energy causes the moon to recede from the Earth. The currently measured rate of recession implies that the age of the lunar orbit is 1,500 million years old. Now get this bit, but the moon is known to be 4,500 million years old. Can you see how his belief is kicking in here? How does he know that the moon is that old? Well, he actually doesn't. That's what he believes. And he believes it because he's been taught the evolutionary story all the way through high school, university, and so on. But he takes it as a given. He goes on. Consequently, it can be argued that prolonged periods of weak tidal dissipation must have existed in the past. But no one's got a mechanism for weak tidal dissipation. So they think at the moment maybe the energy dissipation is very high, perhaps it's, the Pacific Ocean is sort of oscillating in the Indian Ocean, and maybe that's where all the energy is being dissipated, so that the moon's receding much faster now than what it did in the past. Maybe that's how we can stretch out the age. But there is no plausible mechanism which leads to very weak tidal dissipation for billions of years, and now it's high. I think that it's just simply evidence that the naturalistic story of the origin of the moon simply doesn't work. So there are some other interesting evidences on the surface of the moon. There are things called ghost craters. Now this is a photograph of one of the Maria. So we're looking here at a very large expanse of magma, of lava, which is solidified. And can you see that faint circle there with the arrows? There's 2 of them shown in the picture. What's happened here is that while the lava was still molten, there's been an impact from a meteorite. Not too big, not as large as the asteroid that caused the massive lava flow in the first place. And when the lava has solidified, then subsequent impacts have left very clear, obvious craters because they're hitting a hard surface. But those early ones landed on a soft surface, still liquid. So how long would it take a lava flow to solidify? Well, I don't know, maybe weeks or months or something like that. Certainly not hundreds of thousands of years. So what it tells us is that those meteorites struck the Maria fairly soon after the original impact, and not long after that it had solidified, and then we have normal impact craters shown. So all of that suggests that there's been more rapid cratering than what has previously been assumed. So astronomers have tried to date objects in our solar system by counting craters, and then they assume a certain rate at which craters are hitting, or rather meteorites are hitting the object. But if your assumption about the cratering rate is very, very low, then you'll get very long ages. But if the cratering rate is much higher, that implies a young age for the moon. But so too, a young age for every other planet which has been subject to age determination through cratering rates. Here's another one. There are recently formed scarps. These are like, well, if you go down towards Wollongong, south of here, there's an escarpment from the coastal plain, a very steep ridge, and then you're up onto the plateau area. And you can see in that photograph a recently formed scarp. astronomers know it's recent because of the nature of the craters that have incident on that. And they realise that these have been formed by the contracting crust of the moon, which means the moon is getting cooler. So as it cools down, the crust sort of starts to buckle, and suddenly you get one of these scarps springing up. And they realise, well, hang on, if the moon is still cooling, how can it be billions and billions of years old? In fact, it can't be that old. Another interesting evidence is that the moon rocks showed evidence of past strong magnetic fields. But today the moon has got a negligible magnetic field. So how did you have a strong magnetic field and now we don't have one? Well, the moon cannot support a long-term magnetic field, because to do that you would have to have circulating currents in the core. The core is too small, and also you need a rapidly rotating object to keep those currents running. And the moon turns far too slowly. But the creation model has it that God would have created the moon and other planets with magnetic fields, and subsequently they have been decaying. So a past strong magnetic field actually supports the idea of a young age for the moon. You know, the Bible says that we are to demolish arguments and every pretension that sets itself up against the knowledge of God. And I'd want to suggest to you tonight, folks, that the belief that the universe made itself through natural processes, the evolutionary story, is a classic example of a pretension that stops people coming to a knowledge of God. And if you think about it, if the universe just made itself through accidental processes over billions of years, how do we even know that there is a God? And so I think that this would represent one of these pretensions that prevent people coming to know God. And we're called upon to demolish those arguments. Well, how do you demolish these arguments? Well, a great way is to get equipped with the resources that we have. I've mentioned the creation website. We're also on the 5 major social media platforms. Now, if you're on social media, and I'm sure you mostly are, then can I recommend that you subscribe to the Creation Ministries International channel. So the more subscriptions we get on the channel, the more it pushes our results up. And more people find this really vital and important information. I mentioned Creation Magazine, and this testimony came in just recently. This magazine has cleared up questions I have had since I was a kid, and I thank you for this fabulous work. I would have devoured it as a kid. Now I read creation to my kids. So it's just an illustration, I guess, of how people recognise its value, and they're now raising their children on Creation Magazine. My wife and I had 4 children, and they all got good doses of Creation Magazine, and all of them went on to have a strong walk with the Lord. Now, we have the magazine up the back, and we've got some forms there you can have a look at to subscribe. A 1-year subscription gives you access to 4 copies of the magazine. But if you subscribe tonight, then you'll get a free back issue, so you've got something to take away with you and read, and then hopefully to give away to somebody else. And you'll also get access to a digital subscription, which is a great way, by the way, of sharing it with other people. If you subscribe for 2 years, then of course you'll get 2 years worth of the magazine, plus your back issue, plus the digital access. But we're also adding to that this documentary called The Voyage That Shook the World. And it's a streaming video, and there's a study guide that is attached with it. And you'll, in addition, get a 1-year subscription to the Journal of Creation, which is a digital magazine. But it's the forum where the scientists dig deep into the issues surrounding their different disciplines, exploring all of the questions around creation and evolution. But wait, there's more, because you also get a package of 4 little booklets. The first of these is called the Creation Survival Guide, How to Graduate with Your Faith Intact. So if you know someone, in fact some of you here tonight will probably be studying science at school or at universities, this is a great asset to have. And this little booklet called Is Human Life Special?, which covers some of the rather trickier social questions that we confront in our culture today. 15 reasons to take Genesis as history. And this looks at it from a theological perspective, why it matters to our understanding of our faith. And the last one is Stones and Bones, which gives a great mini summary, if you like, of all the evidence in favour of biblical creation. Now, to get a hold of that, up the back you'll find a form that looks like this. Just indicate if you want a 1 or 2 year subscription. Of course, you'll need to put your contact details there so we know where to send it. You can also tick that little box down there if you want to receive the email that way. And if you are already a recipient of the magazine, or if you're sharing your faith with somebody and they're putting up a lot of scientific objections about the Bible, then give them a gift subscription. And you can put their contact details there at the bottom of the form. I mentioned several times the Answers book, which is an absolute goldmine of information, covers the 60 most asked questions that Christians and non-Christians, interestingly, have about creation and evolution. It's a wonderful book. It's like buying a mini library, in fact. If you want to dig deeper in the first 11 chapters, the Genesis account is a great asset. It's a theological, historical and scientific commentary on the first 11 chapters of the Bible. And this is a great little book. It's a collection of articles from Creation magazine on the solar system, all bundled up as a little book there, our amazing created solar system. So friends, when you step outside, if you get a gap in the clouds, or maybe tomorrow evening or a little further on in the week, take a look up at the moon and realise that it's an amazing moon which gives glory to God because it was created recently. It's unique, it's a large single moon like nothing else in our solar system, and it declares God's glory to everyone. So thank you very much for listening. Let me hand back now to Pastor Kevin, and we'll have a brief Q&A for a few minutes before we move on to the next topic.
Thank you, Mark. As I announced before, now we couldn't get the batteries for the mic. If you are to ask questions for just this session, if you can raise the level of your voice, speak up a little, it'll be really helpful. Let's start with the question about biology and creation in the Bible. I remember that a few people had the questions from the afternoon session. Please raise your hand if you have questions. Yep.
I want to know your interpretation of
The Nephilim. So this is in Genesis chapter 6. There's a description of people called Nephilim, and it's kind of interesting. There's lots of different views about them. If you jump onto the website, there's an excellent series of articles on it, and also in the Answers book there's a section devoted to that. There are several different theories that theologians have as to who the Nephilim might be. I won't go through those, partly because I can't remember all of them. I can remember some. Some people think they were the line of Shem, for instance, but that doesn't really hold up. And there are other ideas. But one that makes most sense to me is that they were probably fallen angels. Now, angels can manifest themselves like people, like human beings. You might remember when Abraham he encountered the Lord and two angels that came to bring judgment on Sodom and Gomorrah. And if you read the text of that, it says the two men came. And then in the next chapter it says the two angels went on. And Abraham has this debate with God about whether or not he should save some people or not, right? So angels can manifest themselves like people. And in the New Testament it says, always be hospitable because you might be entertaining angels unawares. So perhaps they were fallen angels that cohabited with human females and produced a race of very evil people. The next reference to them comes in Numbers 13, when Moses sends the spies into the promised land to check it out, and they come back and say, yep, it's fantastic, beautiful, but the people who live there live in fortified cities, and we look like grasshoppers to them, and we could never win, except for Caleb and Joshua, who said, we can take this because the Lord is with us. And there's much debate going on, and then the 10 spies who lacked faith finally said, and we saw the Nephilim there. And everybody panicked, and then it was all over. But of course, none of the Nephilim survived the flood, because only Noah, his wife, and their 3 sons survived the flood. So they were lying. There were no Nephilim there in the land of Canaan, back there, right? So I think they are probably fallen angels. But you'll find on the website there are articles about it, and I think it's in the Answers book. Have we got the alien intrusion book on the table? Yep, we do. So there's a book up there called Alien Intrusion, UFOs and the Evolution Connection. And there's a whole appendix devoted to discussing the Nephilim in that book. Thanks.
All right, next person.
Yeah.
I think also in chapter 6, there's a verse, in verse 6, when it says, the Lord regretted that he had made man on the earth. Does it mean like using the word regret like as a heartbreaking language? Or,
yeah, other translations say that the Lord was grieved that he'd made man. So evil had mankind become. It says that their thoughts were only ever evil all the time. So God knows when a human heart is irredeemable and is going to be unrepentant. Only God can make that decision. And only Noah and his family were deemed to be righteous. It must have been an extraordinarily wicked world. But think about it. Jesus said, when the end comes, it will be as in the days of Noah. So you think about the number of people, see what they exhibited was unbelief. They simply refused to believe, right? Didn't believe in God, they certainly didn't believe Noah. But what we're seeing happen today is people are turning away from God en masse and using, by and large in Western cultures, belief in naturalistic evolution as the excuse to do so. Oh, evolution has proven that the universe got here by itself. You don't need God. So now we have an intellectual excuse to get rid of him. So we are living in ever increasingly evil days. And I think as a church we need to be alert to that and aware of how serious the issue is and how short I believe the time actually is before the Lord's return. Thank you.
Thank you. I'll ask one more person to ask questions about the biology and the Bible, if there's anyone. Yep.
There's one down here. Yep.
How were people in the olden days able to reproduce with family members or relatives, and then not have any genetic siblings?
Good question. How were people way back there at the beginning able to reproduce but without the genetic problems that we have with close intermarriage today? Is that okay? So this is interesting because people say, well, if Adam and Eve were the original created pair, then their sons and daughters would have to intermarry because there would be no one else around to marry. And we all know that close intermarriage runs a high risk of genetic diseases and deformities in children, and besides which, it's actually now immoral. So let's just think about what the original created order would have been like. You see, when God made the world and before sin occurred, it was a perfect world. The reason that close intermarriage produces genetic problems is because every single one of us has copying mistakes or mutations in our DNA. So if you marry someone who's closely related to you, there's a high chance that you will have the same copying mistake as does your spouse, which means that your children are highly likely, therefore, to suffer from some kind of genetic problem. And I can't remember the percentages off the top of my head, but it's a significant increase in the probability of genetic issues. But right at the beginning, there were no mutations. Their genes were perfect. There was no risk from a close intermarriage of producing a genetic problem. It was only after the fall, when things started to run down, that the copying errors started to happen, that these genetic errors started to build up and up and up and up. And you know, with every passing generation, we're getting something like 100 or so more copying mistakes per person per generation. So we're all degenerating, in fact. We're going downhill, not uphill. We're getting worse and worse. And so the problem is, in fact, increasing. But back then, there was no genetic problem. However, by the time of Moses, about 2,500 years after the creation, it was starting to become an issue. And so God, in the law, forbade close intermarriage. And he did it, like God does everything, for our benefit. So he said, don't marry close relatives. And that was given to the Israelites as part of the law. So by then, it was starting to become a risk. So once it's in the law, now it becomes immoral to do that. So we see today close intermarriage, or incest as it's called, is immoral, and it's also genetically dangerous. But back at the beginning, it was not. So there was no problem with Adam and Eve's sons and daughters intermarrying to produce families. Okay?
Thank you. Now we're going to receive some questions about the moon and the Bible and creation. Anyone? I think we can only give 3 people chances to ask questions. Anyone? Oh, over here.
So this is a bit away from the moon.
That's all right.
But with the Big Bang Theory, so you've got like the CBM, temperature, the redshift distribution, and the elemental abundances all matched up with the predictions of the Big Bang Theory. And I'm aware there's the argument of you can't get something out of nothing. Something has to come out of something, as well as we don't know whether or not everything did start from the one point and not just the universe starting from midway through the point, such as the point you made yesterday, I'm pretty sure. But what other, I guess, specific observational, results would lead you to reject that theory as a whole?
The Big Bang, okay. So there was the statement that a number of the predictions of the Big Bang all line up with what we observe. Why would I reject the Big Bang? Is that a fair summary of the...
Yeah, that's a pretty fair summary.
Okay. You need to be a bit careful about some of these things, because a lot of the so-called predictions of the Big Bang are actually post-dictions. They're not predictions. Now, the cosmic microwave background is a classic example. So when that was first discovered, the secularists began to think about, well, maybe it's like the leftover fingerprint from the Big Bang, and they figured out what they expected it to be in terms of temperature. And I'm just not sure off the top of my head I'll get the numbers right, but they were completely wrong anyway, was the essence. So when they finally did some careful measurements, they discovered it was much, much lower than what was expected. But what happens, the evolutionary theory is extremely flexible. So if you find a piece of data which doesn't seem to fit, then you modify some assumptions and you can make it fit. And so they turn contrary data into something which actually fits the belief. But there's a major problem with the cosmic background, radiation background. And the problem is that it's far, far too smooth. Now, the prediction was that the microwave cosmic background should have a lot of structure to it, representing what would have been originally hot regions or cold regions in that initial singularity. The hot regions ultimately condensing down to become the galaxies and what have you that we see today, the cold regions, the interstellar medium and so on. But when they started to do measurements, they found that the distribution was incredibly even. In fact, it's even, or flat if you like, to 1 part in 10 to the fifth, or 1 part in 100,000. So another way of looking at that is to say you have a surface that is dead flat, departs by no more than 1 millimetre over 100 metres, right, to give you some idea of... And that was a big surprise. That was definitely not a prediction. And they have a problem because how did the hot regions share their heat with the cold regions to get the temperature so uniform? The problem being that it takes too long to get from one side of the universe to the other to get uniformity in the temperature distribution, which therefore gives you uniform radiation distribution. And it's called the horizon problem. And there's no plausible explanation for the horizon problem. One of them was put forward by a guy called Alan Guth, and he suggested what's called an inflationary period early on in the Big Bang that starts some incredibly short period after the initial explosion, lasts for an incredibly short time, it starts for no reason, stops for no reason, and during it you have special physics happening where matter repels matter rather than attracting it. And also the expansion takes place many, many orders of magnitude faster than the speed of light. So they basically just abandon all the fundamental physical laws and principles to make the inflationary period work. And its objective is just to flatten the temperature distribution of the cosmic microwave background. But it's completely bereft of any observable or evidential support. No laboratory physics would lend any support at all to any of those things. So it's what I would call a rescue device to try and save the Big Bang model, but without any grounding in actual physics. So it's classic storytelling science. There are heaps of things where the Big Bang goes wrong. In fact, the Big Bang is a very poor model of our existing universe. Another one that just comes to mind quickly, if you convert energy into matter through Einstein's E equals mc squared equation, which apparently is what's supposed to have been happening as this massive energetic singularity burst into material, into matter. When you do that, you produce equal quantities of matter and antimatter. And when matter and antimatter combine, they annihilate each other. So the question is, why is there any matter at all? Because when this energy burst takes place and converts to matter, it would promptly annihilate itself and go back into energy again. So they figured out that there must be at least 1 part in a billion, 1 proton out of a billion protons and antiprotons has to form slightly out of balance, right? So you don't get exact equality between matter and antimatter. And just recently, using the Large Hadron Collider, they've done some measurements. I won't be able to find it quickly enough, I don't think, that demonstrates that beyond that level of precision, there is exact equivalence between matter and antimatter. So the universe should not exist. The Big Bang has no answer to that. Here's another one. The Big Bang violates the laws of thermodynamics. The first law says that energy can be neither created nor destroyed. The second law says that essentially available energy will convert to heat, and so you will have this inexorable downgrading, if you like, of available energy to do work. So the question is, did the universe have a beginning? So if the secularist says, yes, it has a beginning, he's just violated the first law of thermodynamics, because you've got to go from nothing to something. But if he says, well, no, it didn't have a beginning, the universe has been eternal, it's eternal matter, well, now you've just violated the second law of thermodynamics, because we observe everywhere that it's running down. but it has not yet run down, which means it's not infinitely old. So it can't be an infinite universe. So which law of physics are you going to violate, the first or the second? You see, the only way you can resolve the question, did the universe have a beginning, is by invoking a supernatural creator that stands outside of the universe and brings it into being by the power of his word. So the Big Bang, we have a book on our website called, some of the guys help me, what's John Hartnett's book? I just can't, it'll come to me in a little while. But it's an excellent discussion on the whole, all the shortcomings of the Big Bang, which you don't hear about in the general sort of physics courses or popular science kinds of things. But the Big Bang is a very poor description of our universe. It fails at almost every level, actually. But they won't let it go. And the reason they won't let it go is because there's no other alternative than creation. And if there's a creator, there's a God. And we don't want there to be a God. So I'm going to hang on to my faulty theory until I die, sadly. I'm sorry? Thank you. It's called Dismantling the Big Bang. That's the name of the book. You'll find it on our website, written by Professor John Hartnett. He was a professor of physics at University of Western Australia and in University of Adelaide. He's now retired, actually, and is written by Hartnett and Alex Williams together. And it's a wonderful demolition of the Big Bang, worth reading.
Thank you.
Okay.
Right. We're going to receive 2 more questions.
Hey, I want to say thank you for your informative talk. I wanted to ask what you think about life outside of, if there's any possibilities. I don't think about it, but
Okay. Is there life outside of Earth? Is a question. It's a very good question, and people argue, if life evolved here on Earth, then why not somewhere else? And belief in aliens is very widespread. There's a survey done in the US not that long ago, and something like 80% of people were happy to accept the possibility of alien life out there somewhere. Now, the premise, of course, is faulty because life can't evolve here anyway. The barriers to evolution, as I hope you've picked up in this last couple of days of talks, are just insurmountable. So there is no way that life can come about through naturalistic processes. But unfortunately, the general population believes that it can, because that's what we're told over and over and over again, right? Now, there are some theological problems with there being life outside of planet Earth. For instance, just imagine on planet Zork somewhere, there's all these people who are living in perfect innocence, in wonderful relationship with God, and then some bloke called Adam on some planet they've never even heard of rebels against God, and God curses the entire universe to run down in bondage to decay, as it says in Romans 8. So suddenly they're experiencing disease and death, and what's going on? I mean, that's extremely unjust of God to do such a thing. The Bible also says that Jesus is returning for his bride. That is, the church, the company of people who believe in him and have put their faith in him. He's not a polygamist. He's not coming for lots of brides on lots of different planets. He's coming for one only, and here on planet Earth. And the Bible very specifically says in Genesis 1, in that divine council, God says, let us make man in our image. Right? Nobody else anywhere in the universe has had such a thing said of them. And if he so values his relationship with us, surely somewhere in the scriptures he would have mentioned that there are other life forms on other planets, but there's not even a hint of such a thing. So I think there's very significant theological problems with the idea of sentient life external to our Earth. Now that could exclude, say, bacteria, for instance. Maybe a volcanic eruption sent some rocks past through the escape velocity, they went to orbit, landed on Mars, some piece of bacteria survived, But that's not sentient life, right? Life self-aware, capable of thought. I don't believe there's anything like that anywhere in the universe. I don't actually think there's any bacterial life either. I think all of God's creative activity in terms of biological life was focused here on planet Earth. All right?
Thank you. Last question.
So what?